Okay, so we have a couple problems here. First thing we're going to do is this problem that reviews integration. So this is a tricky one. You might be tempted to use u sub right away and let u equal 1 minus 9x squared, but then du would be negative 18x dx. I don't have an x dx. I only have a 1. So then you should be looking at, oh, this kind of looks like a sine inverse. Now for sine inverse, the derivative of sine inverse of x is 1 over root 1 minus x squared. So remember, the s in sine inverse stands for square root and subtract, and because sine comes first, the 1 comes first. I don't know how you want to remember that, but it's 1 minus x squared. It's not x squared minus 1. Okay, so we have 1 minus 9x squared. So what I can do is I can let u equal, so this is what I'm going to do. I'm going to say, okay, this is the integral from 0, 1 over 1/6 of 1 over the square root of 1 minus. So I'm going to make this something squared. So 9x squared is the same thing as 3x squared. Right over here. So if I let u equal 3x, du is equal to 3 dx. Divide by 3. I get dx is equal to 1/3 du. So what I can do is I can pull out a 1/3 integral of 1 over root 1 minus u squared. So I let u equal 3x because then you should recognize that this looks like a sine inverse problem. But I am going to change my bounds. So if I plug in 0 into this, I get u is also equal to 0. And if I plug in 1/6, 3 times a 6th is a half. So I get u is equal to a half. So those are my new bounds. And then I get 1/3 sine inverse of u from 0 to a half. I plug in a half. I plug in 0. And guess what? You cannot stop. I mean, you can stop, but you shouldn't. You need to be able to solve this. So sine inverse, where on the unit circle is my y coordinate 1/2? And that is at pi over 6. And where is my y coordinate 0? And that is at 0. So I get pi over 18 as my result here. Okay. So, you need to recognize that this is a sine inverse problem. There's really there's no quick way to remind yourself. You just have to practice and know that 1 over the square root of 1 minus u squared, the antiderivative of that is sine inverse. So it's just kind of about maybe trying u substitution. It doesn't work. So then you have to look at other rules that you have memorized. Okay, so we're going to have the same issue here. I have 4x squared. I can't let that be u because then I have 8x, but I don't have an x on my numerator. So u substitution is also not going to work here. So like the one I just did, I am going to make this 1 over 1 plus something squared, and that something would be 2x because 2x squared, 2x times 2x is 4x squared. All right, so let's let u equal 2x. So du is equal to 2 dx. Divide by 2. I get dx is equal to 1/2 du. So that is going to be it's going to be 1/2 times the integral of 1 over 1 plus u squared du. I do need to replace my bound. So if I plug in 0 for x, I get 0 for u. If I plug in root 3 over 2 for x, I get root 3 for u. And the antiderivative of 1 over 1 plus u squared, you should recognize, is tangent inverse from 0 to root 3. So I get 1/2 tan inverse of root 3 minus 1/2 tan inverse of 0. Okay, where does tangent equal root 3? And that is pi over 3. You just got to memorize your unit circle. Minus 1/2, where does tangent equal 0? And that's at 0. So we get pi over 6. All right, 2 to the 3x dx. Okay, you could use u substitution on this, but I don't want to. 2 to the 3, that's just 8 to the x. dx. And then I know my rule for an exponential function. The derivative of an exponential function is the function divided by ln of the base. I'm sorry, times the ln of the base. But when I find the antiderivative, it's going to be the exponential divided by ln of the base. So that's just, again, knowing the rules. Plug in 1, you get 8 over ln 8. Plug in 0. 8 to the 0 is not 0, it is 1. So I get 7 over ln of 8. Okay. All right, and then lastly, we have the integral from 0 to 1 of e to the 5x dx. This one I will use u substitution on because I have e, and I'm just going to leave e as my base. So du is equal to 5 dx divided by 5. Dx is equal to 1/5 du. So I get 1/5 times the integral e to the u du. I'm going to go ahead and switch my bounds. If I plug in 1 for x, I get 5 for u. If I plug in 0 for x, I get 0 for u. The antiderivative of e to the u is also e to the u. And so that becomes 1/5 e to the 5th minus 1/5 e to the 0. E to the 0 is 1. And there you go. That's it for your integrals. So you can use u substitution. You don't always have to. For this one, you could have used u substitution, but I just chose not to. Algebraically equivalent is what I'm looking for here. And then these other ones, you just really got to know your rule for trig inverses. These are really good problems. You should expect to see problems like these on future assessments. So you got to recognize like, oh, it looks like sine inverse or tangent inverse. So sine inverse and tangent inverse are the ones that pop up the most. You will not see a ton of cosine inverse or secant inverse or cosecant inverse or cotan inverse. It will usually be sine inverse and tangent inverse that show up on tests, including the AP exam. Those are the ones that always pop up on the AP exam. All right, now for this next problem, we are given that f of g of x is equal to x. So what does this mean? If f of g of x is equal to x, that means g is equal to, take f inverse of both sides, f inverse of x. In other words, g and f are inverses. So any way that this is written a ton of different ways for these problems, it'll be like f of g of x is equal to x, or g of f of x is equal to x, or it might be just say f and g are inverses of each other. But you need to recognize what that means. Now, if g and f are inverses, we have to use the rule that g prime is equal to 1 over f prime of g of x, or likewise, f prime of x is equal to 1 over g prime of f of x. And the way that you can figure that out is if you forget what the rule is, start with your original thing. F of g of x is equal to x. Take the derivative of both sides. So the derivative of the inside is g prime times the derivative of the outside with the inside still plugged in. Derivative of x is 1. So what is g prime? It's 1 over f prime of g of x. So I just want to remind you, like, these are just like the rules. You do need to know those. All right, now we don't necessarily need to use them for each of these problems. So for this first one, it's f prime of g of 0. So that's f prime of g of 0 is 2. All right, what's f prime of 2? 3. For B, g prime of 1. Okay, so I don't have, a thing for g prime. So I'm going to have to do 1 over f prime of g of 1. I have to use this rule right here. So that is 1 over f prime. G of 1 is 1. And what's f prime of 1? Also, f prime of 1 is 7. So we get 1/7. All right. Okay, so that's A and B. I'm running out of space here, so let's do C down here. G prime of 2 is 1 over f prime of g of 2, which is 1 over f prime of negative 1. 1 over f prime of negative 1. F prime of negative 1 is 1, so we just get 1 for part C. For D, we have f prime of g of 2. G of 2 is negative 1. F prime of negative 1 is 1. For E, 3 times F prime. Okay, so this is like pretty straightforward. F prime of 2 is 7. So we just get 21. And then F, 5 times F prime of 1 is 7. 6 times G prime of 1. So G prime of 1 is 1 over F prime of G of 1. So that's going to be 35 plus 6 over F prime of G of 1 is 1. By the way, if I'm going too fast, just remember that you can stop the video, slow it down, etc., etc. F prime of 1 is 7. So I get, I don't know, 35 plus 6 over 7 is fine. Okay, so mostly it's using this rule for inverses. And also just, I mean, really, this is just like using a table to find values. So a lot of this should be straightforward. Just remember that when you have function composition, work inside out. Okay, so like for F prime of G of 0, I started by finding G of 0, and then I found F prime. I didn't find F prime of G and then like plug in. Like I didn't do anything weird there. I just plugged in 0 into G, and then I plugged that whole thing into F prime. So you do need to do these table ones step by step. This will show up this kind of like table thing shows up a lot during the AP test as well. So yeah. Okay, and I just realized I made a very small mistake here. E was 3 times F prime of 2. F prime of 2 is not 7. I read the chart wrong. It's 3, which is 9, not 21.